Automating peace of mind with accessibility testing and continuous integration with Marcy Sutton.
Please give a warm Chicago welcome to Marcy Sutton.
Hello, everyone. Should we check this microphone? This one
that's fine.
This one's for the captions, right?
That's for the stream and the captions.
For everyone on there. Okay. Well, I guess I'll just talk loud enough so this mic picks me up. Hi, everyone. I'm super excited to be here. I'm going to talk to you about the technical side of accessibility. So a bit of a fair warning that I'm a developer, so this will be really technical. But if there's anything that you need extra explanation on, we're going to do Q&A at the end, so I'm happy to answer any questions that you have. My name is Marcy Sutton, as Dennis mentioned. You can find me on Twitter at Marcy Sutton. I work at Deque Systems as a senior front-end engineer. So I work on browser extensions, APIs for developers to test for accessibility, so that we're helping developers figure it out on their own so that you can become self-sustaining at accessibility and really catch those easy bugs that we shouldn't make those mistakes over and over. My slides can be found online at bit.ly/a11y-and-ci. And they're on GitHub too. So a bit of a background about me. At Dee-Cue, I work on the Axe core team, and I'll tell you all about that a little bit later in the talk. And I have stickers, if anybody wants some Axe core stickers, since we have heard now that everyone loves stickers. I have a course on accessibility on egghead.io, where I demo how to do some technical topics, really general accessibility things. Since Egghead had no accessibility content at all, they convinced me to start contributing some videos. And I add to it as time goes on, typically not during conference season. We have a question already? Yes, it is free. Free videos, and they're short, I think under 15 minutes. It's really hard to jam that much content into a short video. I, in the past, have co-led the Seattle chapter of Girl Develop It, which is a nonprofit encouraging adult women in software. I've since moved to Bellingham, Washington, so I don't run the Seattle chapter of Girl Develop It anymore. I actually need to update this slide because I do run the Seattle Accessibility Meetup as of about 2 months ago. So we're hosting a Global Accessibility Awareness Day event there, and it'll be interesting to see what we end up doing. I'm definitely going to take some inspiration from this meetup, since you seem to have great content going all the time. I used to work with the Angular team. I worked on the Angular Material UI framework for almost a year, and I still contribute comments on component specs to the teams at Google, give them feedback on their websites, which need a little bit of help, to be honest. But I am very heavy on the JavaScript side and providing talks and blog posts and things on client-rendered accessibility and JavaScript stuff. A little plug for my blog called Accessibility Wins. It's wins.tumblr.com. And if you've got something that you're really proud of, I would love to hear about it. So you could submit it to me and I will write glowingly about it. It's really hard to find wins out there. So I try to put a positive spin on accessibility. Sometimes it's not perfect, and I'll talk about that in a post. But I try not to let perfection preventing me from highlighting the wins, because we need to celebrate what's going right. So I'd love to hear if you have something that you're proud of. Okay, so this talk originated from experience I had working at a digital agency where we didn't do any software testing at all. And I remember sitting at my desk with my colleague going, I keep experiencing really painful deployments of websites that we've worked on where I broke something and QA, like maybe I broke something on a page I wasn't thinking about because I didn't know I'd reused a component or something, and QA didn't know to test it, and everybody looks bad in that scenario. And I knew there had to be a better way. I'd heard of this thing called software testing, and I leaned over to my colleague and said, do we do any software testing? And he said, nah, we don't. I went, oh. Okay, well, I guess if I want to learn that, I need to pursue that in my career. And so I found another job working at a company called Substantial, and they were really pragmatic about their software development. I learned how to write software tests. I ended up working on the Angular team after that, and that was very heavy with software tests. And I grew to love that as a practice because it was all about software quality. And as time went on, I learned that I could work accessibility into that as well. So I'm going to tell you about that. So imagine this scenario. You just shipped a redesign, you flip the switch on your brand new gorgeous website, and all of a sudden, if you haven't addressed accessibility at all, you could be making your website unusable to 15% of users just like that, because you didn't test it for accessibility. And I think I'm preaching to the choir here. Obviously, we all care about accessibility enough to be here, but we probably all have experienced this, where you see teams who aren't doing accessibility, and that fast, you could push code out to a new production server, and all of a sudden, people can't use it. Or maybe it regresses, and that's a really common scenario. Pretty familiar to everyone here. What is web accessibility? To me, it means that people with disabilities can interact with the web and contribute to the web. And so I keep this in here when I'm talking to really technical audiences who don't know anything about accessibility. If we start with software testing, it's a really great way to kind of open that door to this world of accessibility and talk about how we can make these things work together. So with testing, if you don't have any test coverage at all, you could be one bad deployment away from failure. Like I said, you could flip the switch, all of a sudden your site is unusable. And I have a really amazing animated GIF of a car trying to merge into traffic, and it goes really horribly. And so that's kind of what I think about with a bad deployment. So we want to protect ourselves from that. We want to have some test coverage to help mitigate this ahead of time, so that we're not having to go and tell our leadership team we broke it without realizing it. So software testing, as I learned over time, it's really a winning strategy, but not only for software quality in general, but also for web accessibility. And it made me think of Kramer's coffee table book of coffee tables from Seinfeld, because it's kind of a meta concept. You've got your code, and then you write tests that assert that your code does what you want. And so it's sort of this meta concept, and makes me want to watch more episodes of Seinfeld. So today we'll talk about software quality and how it applies to accessibility, because that's a great way to really try and break through to people who are not caring about accessibility. If you make it a quality issue, not only that it's about people, but you have quality issues, sometimes that's a way to get people to perk up a little bit and start listening. We'll talk about continuous integration, CI. What is that? I'll tell you what that is and how I see that fitting into the accessibility development practice. We'll talk about what we can automate for accessibility, because we can't automate everything. Some of it requires a human to actually test it. And really the overarching thing in all of my talks and all of my stuff is that we can use technology for good. And I think we're probably all on board with that here at this meetup. So getting into some of the different types of software testing, for me, it's all about validating code and covering yourself. Covering your butt from getting this code pushed out there without any tests. So there's functional testing, and that includes unit testing, integration testing, system testing, acceptance testing, and depending on how your company, what level of testing you go to, these fall under functional testing. There's non-functional testing, which can include performance, security, usability, which does get back closer to accessibility, and compatibility with lots of platforms. But the cool stuff to me is all the accessibility testing. And we can automate things like HTML and ARIA validation to make sure that we're using tags correctly. We didn't make up ARIA roles, because I've seen that happen, make up attributes. What do you mean there's a set number of roles? I thought I could just make those up. We can automate checking for form labels, color contrast, accessible names for icon buttons, for example. We can automate testing of focus management in applications, specifying a language, and more. And I have a link to our repository for AxeCore here in my slides of all of the rules that we actually test against. And then on the manual testing side, because we can't automate absolutely everything, we can't really automate focus order. Maybe in your own app you could, but from the AxeCore API level, we can't really determine that. We can't automate the quality of your text alternatives quite yet. Maybe with computer vision we can get there, but for right now, I can't automate whether your alt text is the right person, or really if the quality of your alt text is good. I can tell you if you forgot it, if it's missing, but the quality of those text alternatives is more of a manual process. Screen reader testing, we can't programmatically fire up a screen reader, have it do what we want yet. I'm hoping that changes. There's more with keyboard support. Like if it's not operable at all, we can't really automate. You know, it's like if you don't know what you don't know, we can't really automate that. Contrast of text over images and gradients is challenging, and error identification. In my slides, I have a link on the Dee-Cue blog about our manual accessibility testing approach, and I use that to kind of give myself a gut check about, okay, well, what can we automate and what can't we? So if you want to read more about that, you can find that in my slides. So, but really, technical accessibility, like we do it for the people. It's really about the people. So as much as I harp on, you know, development, yay, technical stuff, yay, we do this so that people can actually use these websites. So we want to keep that in mind. Obviously, I think we all know that. But visual disabilities, hearing disabilities, motor and cognitive, and I have some more background from the WebAIM site, which I just love all of their resources, if you want to read more about those. And it's important to check your work. WCAG, Web Content Accessibility Guidelines, is a really great set of exactly that, guidelines, to help you figure out how to tell if something is actually accessible. The version 2.1 is currently being worked on. There's some new success criteria for mobile and low vision folks. And you can actually provide feedback on those right now. So that's pretty cool. And I think when I first got into accessibility, I kind of went, I don't understand this. And I went for just making it operable and usable using focus management and off-screen text and stuff, and not so much ARIA. But as I've learned about it more, I see this as a really great resource for validating whether something is actually accessible. So much expertise has been put into WCAG that it's really valuable to go and reference. And it's also really important to automated testing. And I bring this up because in our tooling, you know, a lot of times this is what we're checking against. So why geek out over this? Well, to me, it's all about making the best quality software that works for people. And my animated GIF right now is, I don't know if that's from The Office. The guy's just like dancing in the elevator, and that's what geeking out is to me, is when you're just so excited that this is so cool. I think software development and accessibility go together, and it just produces this amazing result. So I geek out over it. I hope you do too. What can we automate? We can only catch roughly 30 to 50% of accessibility issues, and that depends on your rule set. So if you're in another country, maybe you're not using WCAG, it really varies what rule set are we actually testing against, but it's that smaller set of 30 to 50%. And some really interesting work that's happening in this space is the Ottawa CAG Community Group and the Accessibility Conformance Testing Task Force at the W3C. They're actually working to standardize some of these automated tests. And my colleague, Wilco Fears, I work with him on the AXE core team, he's in both of these groups. So it's really cool to see us moving towards a standard for this so that every accessibility checker isn't reinventing the wheel. So if you want to learn more about the standard side of automated testing, I would recommend those two groups, Ottawa CAG and the ACT Task Force. And you can participate in those groups too, which is really cool. But it's worth reminding, just to say it yet again, that automated testing is no substitute for manual testing and getting real user feedback. It's like, just because it's technically compliant doesn't mean it's usable and user-friendly. So we want to make sure that we're doing that. The automated tests are the great first step so that we're not wasting human effort with these low-hanging fruit things like missing alt text and, I mean, the really basic things that we can automate. We want to catch those with automated tooling to free up the more complex tasks for our staff who will be doing manual testing and usability testing. Okay, so let's dive into some technical talking about what can we actually write in our tests. So in accessibility unit tests, they're really great for component-specific behavior. So if you're writing a component that is a menu or an icon button or something that's reusable, you would want to write some tests for that component that are isolated to just that component. So it doesn't reach out to the network, it doesn't pull in other components, it's just this one unit. And that's general in software development. You'd probably also want to test for anything in that component that handles focus or interaction. So the kind of the inputs into that component that would make it do certain things, like take focus, change the state of it internally. Like if it's a custom component and it has some ARIA in it, you would want to validate in a test that those values change when you expect. So you'd write that into a test. Maybe you could write a unit test for something like a text alternative if it was an icon button. And I learned this set of tasks as being more unit tests when I worked on the Angular Material UI framework. So in those components, you're creating components that when a developer uses that component, they might supply alt text in whatever you've decided is part of your API. So that way we would want to test that when the developer puts in text for an icon button, for example, or a form control or something, we want to make sure that it ends up in the right place to expose text to a screen reader. And that's just one example. But you would write a unit test that's sort of limited to just this unit. Here's an example of a unit test. I took this from David Clark. He has put out some really great React components. And he's got this menu button that you can find on GitHub. It's the React ARIA menu button. And he's got a unit test that tests his focus manager. So rather than, the way that he set up his test was actually to test that his focus manager had been called, because that gets triggered by the user's keyboard focus going through a page. So he sets up this menu by setting the menu to be open to start. And then what we're asserting is that if that it's open, that our focus manager is being called to send focus into the menu when it opens. So this is one example of how you might test for focus, but it sort of depends on this higher level API that he's created called the focus manager. So if you want to learn more about how he set up his component, I would definitely recommend checking out his repository. On the flip side, so let's unit tests, you might consider writing integration or end-to-end tests as well. They're really great for real-world browser testing. So in the unit tests, we're often running those in a headless browser like Phantom.js or Karma Chrome Launcher or something like that. And what that does is, in a headless environment, we aren't actually opening up a browser. We're running it on the command line, kind of in memory, and that works pretty well. But if you're really getting into things like the actual focus of an element, you might run into some edge cases with your tooling. And so we recommend that if you're having issues with your unit tests, just write an integration test with Selenium WebDriver. And what that will do is open a real browser instance on your machine. You're driving it with code. So we'll open up a real browser, and you can specify which one. I'll show you an example in a minute. But then you're actually testing it in a real browser like a user would. That's super valuable. It's a little bit slower, so that's why some people don't like Selenium, but it's really reliable. So I would highly recommend it for real-world browser testing. These types of tests are also really great for document or page-level rules. So if you're testing the title of the page or the language of the document. So that's not really a component unit test. That's probably more of an integration test for this overall page. And furthermore, if you had multiple widgets, like maybe you have focus management going between widgets, you would want to write an integration test where they're both on the same page. So that's a case where you would be reaching outside of your single unit. So to test things together, you would want to have an integration test. We can use this environment in the real browser to test color contrast a lot more reliably. We need CSS to be there. We need the browser layout to happen. And we need real DOM APIs to actually test for color. And then lastly, I've seen integration or end-to-end tests with WebDriver be used because the site might be written with a JavaScript framework like Angular. And that framework may not have all the tools you need to write unit tests for keyboard support, for example. And my example, I grabbed from the Angular Material 2 dialog. When Angular 2 came out, they hadn't set up all of the necessary tooling for unit tests. So they ended up writing their accessibility tests in Protractor, which is the Angular layer over Selenium WebDriver. So this dialog example is on GitHub. It's in the Angular Material 2 library. It's written in TypeScript. And so this is an example of just their general tests for their dialog. They've put accessibility tests in with everything else, which is how it should be. When we're testing for our code, we should just add the accessibility stuff to our regular tests. It shouldn't be this add-on special thing. Just write the tests in there because it's a core feature to be able to use the keyboard. So this dialog, they pull in a number of resources to actually be able to test this code. And then they go and get this dialog demo because it's actually open in a browser. They assert in one test that the dialog should open. They assert that you should be able to close it by clicking on the backdrop. So these are features of this dialog. They have and this I would consider an accessibility test. It should close by pressing the escape key. So you can see, like, if you're testing the clicking, you should be testing the keyboard at the same time. So this is a great example of how accessibility tests just go right in with all of the other tests. They have a test that it should close by pressing the escape key when the first tabbable element has lost focus. So if you end up, I don't know, using a skip link or somehow this menu loses focus, they don't want it to get stuck open. I guess it's a dialog, not a menu. But they want to make sure that it doesn't just get stuck open if your focus is somewhere else. So they have a test for that case. And there's all different scenarios depending on how your component is supposed to function. You can both document that in your tests and prevent regressions. So if someone breaks it unknowingly, they've broken the tests as well. So it's really important to have this test coverage. So to sort of illustrate the value of tests, I have a couple of animated GIFs from Twitter. One from Sarah Drasner saying, "But unit tests are passing." So she's holding an umbrella, or whoever's GIF this is, and they open the umbrella, and the top just goes shooting off of the handle. Because they probably tested each part of it, but they didn't test it all together. So it's a good metaphor for your unit tests. Like, you might test every little part, but if you don't test it integrated together, your umbrella might fall apart. Another example from Twitter, this has kind of been going around lately with these funny animated GIFs for tests. So this one from Nick Vasilyev says 2 unit tests, 0 integration tests. So he's drying his hands in the restroom. He goes to put his paper towel in the garbage can, and there's a fan right over it, and the towels blow right out of the garbage can. Because again, they probably didn't test things together. Like when they assembled this bathroom, there was a fan over the garbage can. So this is a really good way to think about testing and why you actually need to do both kinds of tests. So you really want a combination of tests to catch a variety of bugs, both unit tests and integration tests. The unit tests are really nice because they're fast. They give you test coverage for a discrete unit. So if you say you package up your menu component and let other people use it, your unit tests would be really essential for that. But if you're using it in your real project, you need to make sure that everything's working together. So it's important to have a variety of these types of tests. So those are tests for the features on your website or your application that are specific to you and how your design works, how your website is set up. So you want to have custom tests for your application. That way, you know, it is documenting how that particular feature or page is supposed to work, and it provides a contract for your team members so that things don't just start breaking. But there's some tests that would really benefit from pulling in an API, an accessibility testing API, and there are multiple of them. I work on one, which is Axcore. But APIs like this are really valuable because you can save yourself from writing some of this boilerplate that gets you in the weeds that you frankly don't have time for if you're not specializing in that. You just need to get your tests in and get up and running. So an API could help you with accessible name calculation. So, icon buttons, form labels, things like that, where the way that that label is exposed and calculated is pretty nitty gritty, to be honest. Like the way that those rules are applied takes a lot of insider knowledge. And so it would be nice to just not have to worry about that and have an API test that for you. So you're not having to write that test yourself. It could help you with incorrect ARIA usage. Like say you're using one ARIA widget role and you don't have all of the other required child roles, or maybe you spell an attribute wrong or something like that. It's nice to have an API test that for you. And then the API is keeping up to date with any changes with the ARIA spec, like those kind of insider things of like, well, we filed a bug with Apple 4 years ago and they've never fixed it. So having the API test against the real world scenarios is also really useful. So you don't have to keep track of all of that. It can help with color contrast, which is really expensive calculation. It takes a lot of checking styles, computed styles in the browser, and so it's nice to not have to worry about that because it's pretty complicated. Testing tables, whether they're data tables or layout tables, it's nice to not have to write that boilerplate. Things like viewport and zooming problems, so that, again, you're letting an API handle some of this more complicated stuff for you, and you can focus on the tests that are specific to your application. So my preferred API, because I'm obviously biased, I went to work on Axe because I was using it every day anyway. And it's ended up being a really enlightening experience learning from people who know accessibility inside and out. And that is packed into Axe Core. So you can find Axe Core on NPM, and you can get it on GitHub. We just released the newest version, 2.2.0, this last week. And we love getting feedback on GitHub. If you find an issue with it, if you want to submit a pull request, we love getting feedback from people out in the world. So Axe Core, it's github.com/dequelab/axe-core, and it's AXE. So Axe Core is an open source JavaScript library. It doesn't require a network, and it doesn't require an API key. And so you could be on an airplane with no internet and use this to test stuff locally on your machine, which I think is really cool. You can configure it completely. You can turn rules on and off. Rules are made up of multiple checks that are reusable. So you could configure down to the check level if you wanted. We really aim for no false positives. So that means that we're only trying to flag things that are legitimate issues, because if you have so many issues that you're like, that's not a real issue, you're going to start to ignore it after a while. And we really try to keep up on that. It's hard to anticipate absolutely every use case, so that's why we're really open on GitHub, and we love getting issues. If you find a false positive, let us know so we can fix it. And that's one of the benefits of being open source, is that we can all pool this effort together so that we're trying to make it as solid as we can. And that, in turn, goes back to that Ottawa CAG and ACT task force stuff. It's not just Axe Core. This is helping web standards as well. So I really appreciate that movement to make it standards-based. So if we look at a unit test with Axe Core, the idea of it when you pull in this API is that you run the API, and then it returns a results object to you, and you expect that it has no violations. So Axe Core, and we'll look at what it returns in a second, but it returns a JSON object that has an array of passes, an array of violations, and an array of, I think there's incomplete and inapplicable. But the passes and the violations are really the sort of pass-fail for your tests that you want to key into. So in my little unit test example here, I pull in Axe Core using require. You could use import if you're using ES6. There's multiple ways to pull this in once you've installed it from NPM. I'm going to describe this custom component and then say with Jasmine, it should have no accessibility violations. You pass the test a callback function. We include this asynchronous done argument, so that way when we're done with Axe Core, we can tell Jasmine that our test is done. Otherwise, it'll just time out and scream at you. Inside of our test, you can set up any number of options. I'm just passing an empty object. But then we can say ax.run, pass either a selector or an element reference. It's pretty flexible in what you can pass to it. It defaults to the document. We pass that options or an empty object, and then a callback function. And ax.run, which is one of our newer API methods, it added this ability to bubble up errors, which was different. We had to add that support in there. So if ax encounters a problem, it would kind of just fail silently before with our other API method of ax.alicheck. So this callback function, you pass it two parameters, an error and the results. And if there's an error, it'll pass that back to you. Otherwise, you just get this results. So then in this callback function, we can expect result.violations.length to be 0. And that's really all you have to do, because you're expecting that it's going to return something to you. And if it returns violations, you have to go fix them, and you can kind of iterate on that until it passes. And then you can call this done callback, and that's how you could expect accessibility violations with this API. So another example of this, an integration test with another tool. So AxCore is just the JavaScript engine that powers both our browser extensions and the JavaScript library itself. We have another tool called Ax WebDriver.js that instead of using the headless Phantom browser, we're using Selenium WebDriver to programmatically open a real browser instance. And I'll show you how that works in a minute. But in this test example, we pull in Ax Builder by saying require Ax WebDriver.js. We pull in Selenium WebDriver and cache that in a variable called WebDriver. And then we set it up by saying var driver equals WebDriver.builder. And then we can specify which browser. I'm specifying Chrome. You could say Firefox, Safari, depending on if you're on a Mac, or Edge if you're on a Windows machine. And that depends on having there's a driver that you have to download and put it somewhere on your path on your machine. And if you have questions about that part, let me know. I think we document it on the Ax WebDriver.js repository on GitHub. It can be a little tricky, but once you know like which folders are on your path, you can just go put the drivers there when you download them. I will warn you that Chrome is the most reliable. Firefox has been really unpredictable lately. So once we've set up WebDriver, we can say driver.get and point it at a URL, either a localhost URL running on our own machine, or it could be out on the internet somewhere on a fully qualified URL. That returns a promise. So we can say that it's driver.get, and then we pass a callback function, and we can call Ax Builder now. So we've let Selenium go out and get this resource. It returns a promise. Now we can run Ax Builder on it. So Ax Builder, we pass it the driver variable and say axbuilder.analyze. And in this callback function, it's really similar to our last test that we saw. It passes back the exact same results object. So once we have that results object, we can expect results.violations.length to be 0. And you can name that parameter whatever you want. It was result in the last test. It's results plural in this test. It's whatever you call it, really. But the structure that it passes back is the same. So let's run this test locally. I'm going to run the WebDriver version. So I have a command prompt in my browser, which is not available on my slides because that would be a big security hole. But locally, I have it running in my slides. So I can just say npm space test. So npm test running in this directory. You can see it exited out of my slides and opened a real browser. I'm running this Mars commuter website that we use. It's atrocious for accessibility. It's a really great test example. So it opened that browser instance. I went back to my slides, and in the command prompt now, we can see that it expected there to be 0 violations, but there were 10. So that's a problem. But that's how it would really work if you were running this for the first time, is you would get these violations and then go and figure out what failed. So the output that AxCore gives you is a JSON object. And in my test, if I logged out results.violations, I can look at just what failed. So just the violations. And it gives us back this structure. So I'm going to do a quick search here for description. And there's quite a few of them. Things like buttons needing discernible text. And it gives you a help URL, so you could go and learn more about how to fix it if you needed remediation help. It'll tell you which elements were the problem, so you can go and find those. And this is the same details that we use for our Chrome and Firefox extensions, but it's programmatic. It's in an API. The Mars commuter site has issues with color contrast, and it'll tell you what the contrast ratio was. So 4.49 is so close to passing. 4.5 to 1 is what it should be, but 4.49 is not passing, technically. So you could just bump that color up a little bit, or maybe the font size. We do take font size and boldness into account when we calculate that. That site had issues with ID attributes not being unique, iframes not having a title attribute, the HTML document element not having a lang attribute, images missing alt text, and so on. So it'll give you all of these tips of how to fix these really easy things that hopefully we can just knock out and then focus on the more complex issues. And I should add, if you want to see everything that's part of this Axe API, on GitHub, we have our API documentation. And that's dqlab/axecore. So to talk about continuous integration, we had to cover software testing, because otherwise, what would you be testing against? So I like to talk about that first, just so that we know this really important part of continuous integration is before you can actually do continuous integration, you need something to test. But this idea is that you have code and it has tests. And if you're going to push that code out to another server, you want it to run your tests automatically, so that if there was something about that environment that you didn't expect and your tests don't pass, you could have it automatically tell you. You could have it light up somebody's desk with a red light and be like, haha, they broke the build. You could do that with continuous integration. You could have a drone fly over to them and squirt them with a water gun. I don't know. So continuous integration is this idea of pushing code out to a server, having it automatically run your tests, and then report back to you the status. And there's a great article from Carnegie Mellon on continuous integration in DevOps. There's tools that I'm going to tell you about that have made this really easy for us as front-end developers and people who aren't DevOps people to learn about how we can actually make this happen. How can we run these tests automatically without having to become DevOps experts? So there's quite a few solutions for this. There's Circle CI and Travis CI, and then there's Jenkins, and there's probably more, but these are the really popular ones, at least from the front-end land. I'm going to focus on Circle and Travis, because honestly, Jenkins is like a can of worms, and it has been really challenging, especially if you have multiple code repositories that you need to build together. We've just been having a heck of a time with Jenkins. So if you're a Jenkins master, props to you. But we're going to focus on the hosted ones, because that's really the difference between Circle and Travis. They are hosted solutions that are free. Jenkins is something that you can easily set up. There's great tutorials on setting up Jenkins, and that part was easy. But actually getting it to trigger at the right time, I found, was really difficult. So here's a real-world scenario of how continuous integration might be beneficial to you. If you have a GitHub repository, like we do for AxeCore and AxeWebDriver.js, when someone contributes code, Travis, I think we've since moved to Circle, but when someone commits a pull request, our tests automatically run. And so if their code that they're submitting breaks our tests, they know, we know. We don't push their code into our bigger repository until the tests are passing. So that's how you can protect yourself from breaking everything all the time. And so this is a really simple example that I find this is easier to wrap my head around. You're participating in open source code. You want to make sure that their tests are passing. It's the same process if you were deploying a new website out to a server somewhere. But this is where you might find it in the real world all the time, is on GitHub. So we can have our tests run if we commit a new branch, if someone submits a pull request. We can run it in all kinds of different scenarios. Some other tools we have here on GitHub, we have an automatic contributor license agreement. If somebody has signed our document to say they're okay with submitting code to our repository. And then we have this sneak security check too, so we can check for any vulnerabilities in any dependencies and things like that. So there's all kinds of tools and integrations that you could put into a GitHub repo, and this CI fits in really nicely. So hosted continuous integration in a nutshell. You would write your code and write some tests, because you need the tests to begin with. We covered some really great ways to write tests for accessibility. You have to add the integration to a Git repo, so either on GitHub or on Bitbucket. And these are the processes that, at least from the front end, this is how it normally works. Then you go over to that, either if you're using Circle or Travis, and I'll show you what this looks like in a minute. You actually have to go off to that site and enable builds for your project. So it's sort of a two-step process. And then you either push code or you can manually trigger a build. And that's how you can get these tests to run on the hosted CI services. The CI, both Circle and Travis, have default settings. They have certain languages already running, like Node or PHP and things like that. But if you need a specific version that's newer than what they provide to you, we use a lot of newer JavaScript features in our tests. And so the default version of Node.js is too old for ours, so we have to override it. So I have a circle.yaml file is how you would override Circle's default Node install. And then on their documentation that you can find on circleci.com, their configuration has all of these different things that you can do. You could have it deploy your code to production after your test pass if you want. You could pick which branch. There's all kinds of different scenarios that you could use in CI. But from the most basic standpoint, all we really needed was to upgrade the Node version. Travis is really similar. Instead of circle.yaml, it's travis.yaml. And their API is slightly different. So I spend a lot of time on these docs, figuring out how to craft these files, and takes a couple tries. I fail a lot, but it works eventually. So this is a really similar document that shows how to upgrade Node, and if you were going to deploy your code, how you might do that. So how does CI help for accessibility? Well, it really helps you test on more platforms that you don't have physically in front of you. If I'm a Mac user and I want to run it against Edge or some Linux version, or maybe mobile devices using Sauce Labs or something like that, it really expands your reach to these other platforms that can be really useful if you're writing accessibility tests. You can prevent regressions. So if you have accessibility test coverage and a teammate breaks it and doesn't realize it, you can prevent that code from getting pushed out to the world because they broke the build. So that's really valuable because not everyone is an expert. And so if you have some test coverage that people on your team have written, and then you have other team members come in, it really helps document how that's supposed to work in your actual tests. And then from a really basic level, it encourages test coverage at all, because you can kind of gamify it and say, we want these things to turn green, we want them to pass, and we want to protect ourselves from pushing broken code for accessibility. So here's an example. I'll walk you through how to set up CI testing for a GitHub repo that I have. It's called Axe Jasmine Unit. It's just a little demo of how to use Axe, Core, and Jasmine together. So I already had this repo, and I knew that it had some sort of simple tests in it. That project, if I open it in my text editor, it has a package.json file. And in that file, I have some scripts. So I can say npm build or npm test, and then tell it what to do. And so my npm test command runs grunt Jasmine. So I have grunt, the JavaScript task runner, and then it pulls in Jasmine, the grunt contrib Jasmine module, I guess, I installed from npm. And I have a single task because this is a really simple demo. It's just showing how to test. So I init grunt with Jasmine, and in this test object, I point it at a source file of Axe Core. And I'm just pulling Axe directly from the node modules. So it's node module /Axe Core /Axe.js. And that will tell Jasmine about this JavaScript file. So it will inject it into this test environment, and then we have access to that in the global namespace. For the options in Jasmine, I tell it where my tests live. So you could put them in any folder, but I have them in a spec directory. And then using wildcards, I can just say, hey, run any file in this folder. And so it'll just automatically pick up any files that you add in this task. And you could use Mocha. That would be another test framework. It's really just, this was an example that I had using Jasmine. So in the test itself, I describe acts, because that's what we're testing in this example. I'm including a fixture dynamically. So how you include the code that you're actually testing can vary. You might have a component that you instantiate with JavaScript. You might load something. There's all different scenarios. The quick and dirtiest way that I could just isolate my tests was to put some strings of HTML. So I have a button that's cool. It's a taco button. It's the coolest button ever because it delivers tacos. And then I have a broken field set. So I have a field set with an input but no label. So I know that's broken and I expect it to be broken. So my two tests here assert that Axe should report that good HTML is good. I pull in just using document.getElement by ID. So in this environment, I can use browser DOM APIs, which is really cool. So I can go and grab that taco button by its ID. I can say axe.run, pass it a reference to this particular part of the fixture. And then I can tell Axe to do its thing with that same call that we used before. And when it passes back the results object, I expect that it has no violations. In the second test, I expect that there's a violation. So the test passes even though it has broken HTML in it, which is kind of a mind game. But the idea is that I have these two examples, and they're checking the quality of this HTML against Axe core. So I had these two passing tests. And to hook up CI for this, on GitHub, as long as you have access and permissions to the settings tab of the repository, it's kind of a minor detail, you can go into settings. Under integrations and services, there's this little drop down that says add service. And there's a ton of stuff in here, but both Circle and Travis are options. So you can go and set up Circle. It gives you this little screen that says add Circle CI, and you can leave the domain blank and just hit add service. It's really easy. And then once it's there, you can go back to your settings tab and see which integrations you have. That's where you might have other things like the sneak security thing or our little CLA checker. So any integrations for that repo would be listed in the settings. So then I go over to Circle CI's website to make sure that I actually have this binding set up. So the repo has given permission. Now we have to go over to Circle and tell it about this repo. And so I go in all my projects. I'm showing it has both GitHub and Bitbucket because we use both at Dee-Cue. But I can go into my own GitHub account and find any projects and go make this association between the GitHub repository and Circle so that they're friends now. And rather than push code, the first time I ran this, I just hit build project. And it would go and run the test right then. Otherwise, I would have had to push updated code to get them to run. That'll happen the next time I push code. But I wanted to just run this right away, so I hit build project. And they could really use some better color contrast on their site. But once I've got that, once I've built this project, I can see that it says success, and it has this green. An example in the real world of where you might have a bunch of tests, you might have a bunch of passes and a bunch of failures. We had to get our configuration set up correctly. So this is a Circle example. It was failing for a little while. And so if you have it failing, it's like, I feel so drawn to fix it. Need to fix it, it's broken. So it's a good reminder of the health of your code. Like, is it passing? Is it failing? Who broke it? And it'll tell you who broke it. So Dylan broke it. I broke it too. We all break it. It's fine. You fix it. That's part of the process. But that's how you hook up a GitHub repository to CI. And then when it runs, anytime we push code or if someone pushes a pull request, it will automatically run all of our tests. But you have to have tests to begin with. It's kind of the big caveat. So there's some gotchas. This was just some things that really caught me off guard. Things that hopefully will help you. And I have a GIF. Gosh, I'm blanking on what show that is. It's Parks and Rec. I knew it was Leslie Knope. She's sort of like a bigger figure to me than just a TV character. Like Leslie Knope is amazing. But there's an episode where they get her good and it's got a big red stamp over her face saying, gotcha. Gotcha. Okay, so if you see this, I have a little bit of code from my test running locally. Or actually, no, I could reproduce it locally if I had this same scenario. So this I saw on Circle. My tests were failing. I go to look at why, and it says, it's running our parallel browser tests, and it says, loading test WebDriver.js tasks error. Syntax error, unexpected token, ... Took me a while to figure out what that one was. So turns out we use ES6 features, including the new spread syntax. So that's a new feature in JavaScript that depends on the version of Node.js that you're running. And as I mentioned, the version that Circle and Travis installs by default is really old. So if you're using newer JavaScript features and you see this unexpected token ... you need to go and tell it to use a newer version of Node. And that's happened to me multiple times. So I thought it was worthy of telling you about so you don't have the same problem. So yeah, just upgrade the Node version. In those config files, that's how we upgrade it. And then you can use features like ES6 in your tests. So in our tests, we're not as worried about compiling to old versions of JavaScript because they're tests. Whereas in your code that you're shipping to users, you probably want to transpile it back to ECMAScript 5 and stuff like that. In tests, though, we can get fancy. So here's another one. If you see this, you should try and reproduce your tests locally. So figure out if you can run your tests locally like I did in my slides, how we had the command prompt. And ideally, you can reproduce it there. If you can't, and here's an example of what I found was our color contrast sticky header test was saying type error undefined is not an object. And it was trying to evaluate what the reason was that we couldn't tell, like your color contrast was passing or failing. And further down in the test that's failing, it says uncaught. So there's an uncaught exception in the code, but only on CI. It wasn't happening locally. So how do you get around that? That was kind of a tricky one. So I add logging. It's like how I started with programming back in ActionScript Flash days was trace all the things. So in our Mocha tests, the Mocha grunt task that we were using had this option to log errors. So if I change that to log errors true, CI might start actually reporting what failed. Otherwise, they try to suppress them by default. And if that isn't an option, maybe you're not using Mocha or your test framework is just really quiet about what failed or like what error actually occurred. You can wrap that new code, whatever code, if you've figured out where it's failing, you can wrap it in a try-catch in JavaScript. So you put the code in the try block, and then if it fails, in the catch, you just console log the error. And that is really hacky, but it works. So that's how you can figure out what failed and then have it report back to you. And that, without fail, is like my #1 debugging tip for CI. Because otherwise, it's just a black box and you have no idea. Like, why was that datum.reason object undefined there? I have no idea. But I was able to debug it and add some more checks and conditionals to say, hey, if this is broken, don't die. Just move on with your life. Or here's a default value or whatever. So if you are having trouble debugging, the try-catch is totally worth checking out. And if you have all the stuff set up, you can do really funny things, like I mentioned, with lighting up someone's desk or having a drone go over and surprise them. I wrote on Twitter, I was trying to find, I knew the Angular team in the Google office had a big monitor of their build status, and I happened to be there one time when I broke Angular. It was amazing and horrifying. But I didn't have a picture of it. I'm like, oh, why didn't I take a picture of it? Somebody else had a cool monitor where anyone who broke the build, it would say wanted for crimes against Babel and have a made-up reward. And it would say how long the build had been broken. I think this is kind of old. It says 2014. But it's a really funny way to kind of gamify fixing your code, especially if you have accessibility tests. Like you could, depending on what failed, you could probably get really fancy with your build monitor. And it makes it a collaborative effort and, not such a nightmare. It could be sort of a funny experience. Like, haha, we broke the build, let's go fix it. So that was one example of tracking who broke it that you could do if you had CI hooked up. So your end all goal is to both write software tests and then get them passing, because it's just super satisfying to feel like your code is covered, so that you're not pushing code out there and just going, well, I hope it doesn't break. Because I've done that where I didn't realize that I was breaking something on another page. Like, it happens. We're human. We make mistakes. But if we have test coverage, that way we know about it. Maybe it fails a build and it doesn't push the code to production. Whew, you have like another day to fix it, and you're not spending, all night trying to fix it because it's broken out in production. These are really pragmatic ways that we can get more accurate and more professional about how we push code to new environments, including for accessibility features. So you can be yes, like Kip from Napoleon Dynamite, because anytime a test pass, I still go yes every time. Never fails. So to recap, we can automate about 30 to 50% of accessibility issues. I wish it was more, but that's the real world. That's how it works. But the benefit of automating those issues is that it frees us up from having to spend our human time debugging things that we can catch with computers. So I think it's really valuable to have that practice. You want to write a mix of unit and integration tests so that you're catching a variety of bugs, so that you have really solid features that you're contributing, but you don't have those bathroom issues where the paper towels were blowing everywhere because we didn't test it integrated. You can expand your platform coverage using continuous integration so that you can run your tests in environments that maybe you don't have physically in front of you. You want to watch out for gotchas, because that's sort of the real world application of this, is that when you're actually trying to debug why your test failed, that logging might really save you. But don't forget about manual accessibility testing and usability testing, because we're only scratching the surface here with what we can automate. So we want to make sure that things are actually good experiences for our users. So with that, I think we could do some Q&A. Thanks, everyone.
What I'll do is I'll use this microphone.
Thanks to our presenter, Marcy Sutton. Visit her on Twitter at twitter.com/Marcy Sutton. Also on GitHub at github.com/Marcy Sutton. Thanks to our co-host for this event, the Chicago HTML5 Meetup. Visit them at meetup.com/Chicago-HTML5. Thanks to our venue host, Sapient Razorfish. Visit them at sapientrazorfish.com. Captions provided by ACS, Alternative Communication Services. Visit them at acscaptions.com. Captions sponsored by McDonald's. We're loving it. Thanks to Sticker Giant for our Meetup stickers. Visit them at stickergiant.com. Thanks to Rosenfeld Media. Save 20% off really great books. Use code A11YCHI. Visit them at rosenfeldmedia.com. Thanks to O'Reilly Media. Get 50% off ebooks and 40% off print books with code PCBW. Visit them at shop.o'reilly.com. This has been a production of the Chicago Digital Accessibility and Inclusive Design Meetup. Visit us at meetup.com/A11YCHI. Visit us on Twitter at twitter.com/A11YCHI. Visit us on Facebook at facebook.com/groups/A11YCHI. Visit us on LinkedIn at linkedin.com/groups/846 3995.